All right, guys, let's go ahead and talk about the notes and content from lesson 3.2 on parallel lines and transversals. All right, so to kind of summarize what you guys did in the CLT before this, all right, you proved by doing that with the people in your group that corresponding angles are congruent. One second. All right, we're back, I think. There we go. All right. Alternate interior angles are also congruent. Alternate exterior angles are also congruent. And consecutive same side interior angles are supplementary. So they're adding up to 180 degrees. All right. We're also going to use some things from the previous unit where we looked at vertical angles are always congruent and angles that form a linear pair are always supplementary. So this is important because we're going to be talking about two parallel lines cut by a transversal, all right, which is going to give us a lot of this other information. There's new stuff, but the vertical angles and the linear pair do not have anything to do with the parallel lines, okay? So all that stuff is still applicable even if we don't have that. Okay, so let's look at these four theorems. We're going to start to do our best, at least I'm going to help you guys start to use these theorems to kind of how you talk about proving some things, how we answer some questions in the examples as well, because we're going to get to a place where we need to know these theorems to help us do some geometric proofs, which is coming up pretty soon. So these are the four theorems that we're going to be looking at. You can see the figure there where we have line P and line Q are parallel because we have that symbol there, and right here we know that they're parallel. We have a transversal line T, so that's how we're going to use all of these theorems to say all these different angles are congruent or supplementary, things like that. Okay, so again, we're going to be using these four theorems to help us with our proofs. All right, so let's do an example. We're given a new figure here to the right where an angle is 120 degrees. We're going to identify out of the rest of these, so 2 through 8, the ones that are also 120 degrees. And when I do these, I'm going to also use one of the theorems or make mention of how I know that. Okay, so we're not just going to write the answers, these angles, and be done. I want to get you guys practicing, giving the reasoning for why you're choosing this. Okay, so the first thing that I noticed, they have the same measure as angle 120 degrees. Right, the first one I thought of was the one that is angle 4. Right, angle 4 is a vertical angle at 120 degrees. So the measure of angle 4 is 120 degrees because it is a vertical angle of that 120 degrees. That was like the first thing that I thought of. All right, again, doesn't really matter the order here. Okay, so that's kind of the first one. The next one I'm going to choose is this angle 5. All right, this angle 5 is also going to be 120 degrees because these lines are parallel, because this is a transversal. Angle 5 is corresponding with angle 120 degrees, right? Those are corresponding angles. So the measure of angle 5 is equal to 120 degrees because of the corresponding angles theorem. All right, so that's one of the theorems on the previous page. Okay, then after that, what I notice is that angle 8 is also going to be 120 degrees, and you can do one of two options here. You could say angle 8 is also 120 degrees because it's a vertical angle with angle 5, but I'm going to use a new one. So the measure of angle 8 is also 120 degrees because of the alternate exterior angles theorem. You can see with these two angles, I'll highlight the original. All right, there's the original. You can see that the 120 degrees and angle 8 are alternate exterior angles. So because of that, and I know that they are congruent, I can use the alternate exterior angles theorem to say they are the same. All right, so to summarize, measure of angle 4, the measure of angle 5, and angle 8 are all 120 degrees. All right, let's do another example. So finding the value of x. All right, so the first thing I notice with this diagram is that we have that angle 4, which I'll highlight here, that angle 4 is a vertical angle with 150 degrees. So because of that, right, angle 4, measure of that, is also going to be 115 degrees because of vertical angles. Okay? Now, one thing we talked about on those theorems previously is that angle 4 and this angle here are consecutive or same side interior angles. So angle 4 and that angle x plus 5 expression are consecutive or same side interior angles. And I'm hoping that you know now, after we proved it in our CLT, that these are supplementary, which means they add up to 180 degrees. So I have angle 4 plus x plus 5. I'm going to make this a little quicker. I'm going to erase that angle 4 and actually put what I know it is. I already know it's 115 degrees. So angle 4, which is 115 degrees, plus this x plus 5 angle has to equal 180. So now I have x plus 120 equals 180. I'll move this way to get the answer. So x equals 60. All right, so that's using some of our previous understanding with vertical angles and then our new understanding with consecutive same side interior angles. And these are supplementary. Okay, let's do one more example. All right, so this last example, example 3, they're giving us two parallel lines again, which means we are free to use those theorems. And we are given a transversal. We know that angle 1 is 65 degrees. So this is 65 degrees. So I'm going to try to find the rest of these, 2 through 8, and give you the reasoning behind it. Okay, so angle 2, my first thought is angle 1 and angle 2 are linear pairs. So a linear, oh no, don't need to write it there, I apologize. A linear pair with angle 1. So that means 180 degrees would be the sum of those two. So 65 degrees subtracted from 180 will give us 115 degrees. Okay, angle 3. Now when I look at angle 3 compared to angle 1, I notice those are vertical angles. So those are going to be the same. They're going to be congruent. So angle 3 and angle 1 are vertical angles. Okay. Angle 4, you got a couple options here, so if you decide to do something differently, that's fine. I'm going to say that angle 4 is the same as angle 2 because they are vertical angles. So angle 4 and angle 2 are vertical angles, so they are congruent, which is why I wrote the same as angle 2. The measure of angle 5, I'm going to use one of our new ones here. Angle 5 is corresponding with angle 1, so they're going to be congruent. So I'm going to say angle 5 and angle 1 are corresponding angles. Okay. And then I'm going to do angle 6, which is, I'm going to do let's make it fun here. I'm going to do angle 6 and angle 3 are consecutive interior angles. So they're going to add to 180 degrees. Again, that's not the only one you could use. So I'm going to say angle 3 and angle 6 are consecutive interior angles. So those are supplementary. Angle 7, I'm going to say, just for fun, I'm going to say angle 7 is the same as angle 1 because they're alternate interior angles, excuse me, alternate exterior, my bad. So angle 1 and angle 7 are alternate exterior angles. Okay, and last but not least, angle 8. You got so many options here. Let's just do for funsies. I'll do angle 8 and angle 4 are going to be the same. They're corresponding angles, so 115 degrees. So angle 4 and angle 8 are congruent because they are corresponding. Anyway, you got the hang of this once you start to see the relationships for how to do this. There's some check your understanding problems at the end of this paper. You try doing those, and then come see me if you have any questions. Good luck.